In this session, we shall have a look at vitamin B5 or pantothenic acid. So these are the various sources over here in this picture which provide us with vitamin B6. Let's look at the chemistry of vitamin B5. Sorry, it's vitamin B5, also called as pantothenic acid. It consists of beta-alanine in peptide linkage with dihydroxyl dimethyl butyric acid or pentoic acid. So when there is beta-alanine and there is a pentoic acid or dihydroxyl dimethyl butyric acid, then there is formation of this vitamin B5, also called as pantothenic acid. The free acid is soluble in water and it is hydrolyzed by acids as well as alkalis. So it can either be hydrolyzed by acids or by alkalis. It is thermolabile and destroyed by heat. That is, it is weak. It is so weak that it will easily be destroyed if heat is supplied or this substance is heated. Biologically active form. The active form is coenzyme A. In tissues, this vitamin, that is vitamin B5, is present almost entirely in the form of coenzyme, that is coenzyme A. It is also known as coacetylase. So this is coacetylase, coenzyme A, and largely bound to proteins. So it is largely bound to proteins, hence the term apoenzyme. It may be released from this combination by certain proteolytic enzymes, certain phosphatases, and a liver enzyme system. So since they are associated with two or more substances, it can be released from the combination by using some enzymes or some liver enzymes, etc. In many microorganisms, including yeast, pantothenic acid is synthesized by direct coupling of beta-alanine and pentoic acid, as we have already seen previously. Beta-alanine is formed by decarboxylation of aspartic acid and pentoic acid from alpha-ketoisovalerate. So we need to keep in mind that beta-alanine is formed by the decarboxylation of aspartic acid and pentoic acid from alpha-ketoisovalerate. Human tissues cannot synthesize pantothenic acid. Hence, we need to supply vitamin B5 or pantothenic acid through our diet. In addition to dietary sources, synthesis by intestinal bacteria supply fair amount of pantothenic acid, but we cannot fully rely on these bacteria for our daily requirement. Hence, we need some dietary sources to be supplied to us with these vitamins, especially the water soluble vitamins. The concentration of pantothenic acid in whole blood is 15 to 45 microgram per 100 ml, that is average is 30 microgram per cent. It is present in all tissues in small amounts. The highest concentration occurring in liver, that is 40 microgram per gram weight, and in kidneys it is 30 microgram per gram weight. Catabolic products of pantothenic acid are not known. Under ordinary dietary conditions, about 2.5 to 5 mg are excreted daily in the urine. Through sweat, it is 3 to 4 microgram per 100 ml, and milk secretes 200 to 300 microgram per 100 ml. So actually the exact catabolic product of pantothenic acid is not known, but these are the basic statistics through which it is excreted through urine, sweat, and milk. Moving on to the occurrence and food sources. It is widely distributed in plants, animal tissues, and food materials. Excellent food sources include kidney, liver, egg yolk, yeast, cereals, and legumes. Fair sources include skimmed milk, chicken, certain fishes, sweet potatoes, and molasses. So these are those food sources which provide to us with vitamin B5 in fair amounts. Most vegetables and fruits are rather poor sources of vitamin B5. The richest known source of pantothenic acid is royal jelly. It is also rich in biotin and pyridoxine, as we have already seen in our previous sessions. It needs to be noted that 57% loss of pantothenic acid in wheat may occur during the manufacture of patent flour, and about 33% is lost during the cooking of the meat. So when there is cooking of a certain meat, that time there is loss of this vitamin. Also, most of the vitamins, even for example vitamin C, it loses its activity or property when it is heated. So they are thermolabile. Most of the vitamins are thermolabile. Moving on to the daily requirement. First of all, the daily requirement, human requirement of vitamin B5 or pantothenic acid is not known due to its widespread distribution. Requirement increases in the presence of severe stress, like for example in cases of acute illness, burns, severe injury, etc. Oral administration of broad spectrum antibiotics, in pregnancy and lactation, in growing children, and in convalescence. So that is it for today's session on vitamin B5. We shall continue with other vitamins in our upcoming sessions. Stay tuned for more such videos. Thank you very much.